Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study and solve the problems on resolution of a force. Let us begin with what is the resolution of the force? Resolution of the force is the process of dividing the resultant force into horizontal and vertical components. The horizontal component, here it is, resultant force is R, and the horizontal component, R is the resultant component, R is the resultant, and the horizontal component is R cos theta, and vertical component is R sin theta. Here the component is horizontal, that means it is parallel to axis X, and the component is vertical, that means it's parallel to axis Y, and it is parallel to axis Y. The parallel to axis X, and it is a parallel to axis Y. Now this process is known as the resolution of a force. Here in this figure, if you observe, figure 1.1 is the coplanar forces, coplanar concurrent force system. What is the coplanar forces means? All forces acting in one plane. That means XY plane. We considered here it is XY plane. This XY plane is considered as the same plane, one single plane. On that plane, all forces are acting, R1, R2, R3 are acting at one point O. It's the same plane, number of forces are acting, and concurrent meeting at one point O is known as concurrent. This R1, R2, R3 is known as this forces system. This figure represents the coplanar concurrent forces. So if you may understand that, what is the parallel forces, coplanar parallel forces? This is the parallel force system. The coplanar parallel forces. This system is known as the parallel forces. Are these forces are acting at one point? No. These parallel forces acts on the body. Suppose if we consider the forces system, it is the body which is acting on that. Some force at this point, the force is pulling down. At this point, the force is pushing up, here also, and here also. So these are the parallel forces system. But here in this module, we studied the coplanar concurrent forces and its resolution, how to resolve this coplanar concurrent forces system into horizontal and vertical. So what is the importance of this resolution of a force? The resolution of a force system is very, very important in order to find out the resultant force and its magnitude and direction. The resultant force, magnitude and direction, how can we find out? We will see it here. What we will do here, we will resolve the horizontal and vertical. It becomes R1 cos theta 1, and here vertical R1 sin theta 1. And similarly here R2 cos theta 2 and R2 sin theta 2. And R3 sin cos theta 3 and R3 sin theta 3. So when we observe that all algebraic sum of all forces which are parallel to x-axis, that is H equal to, for this case, H equal to R1 cos theta 1 plus R2 cos theta 2 plus R3 cos theta 3, because here only these three forces are acting. And what about vertical? Algebraic sum of vertical forces, that is R1 sin theta 1, V vertical forces equal to R1 sin theta 1 plus R2 sin theta 2 plus R3 sin theta 3, V. Now H and V we know values. What is the resultant? The resultant force R equal to under square root of H square plus V square. This is the resultant force. What is the direction? This it is the magnitude of the resultant force. What is the direction? The direction tan theta equal to V by H, theta equal to tan inverse of theta equal to tan inverse of V by H. Now here, why it is the tan theta here? Why not cos theta or some another theta, some another trigonometric function? Because here, if you understand, this is the H values and V is the positive value. So we want resultant. The resultant represents, according to parallelogram law of forces, these H and V are representing the two sides of a parallelogram. Then here the point, the diagonal represents the resultant. This is the R. Now this is the V and it is also V. And this is the direction with the horizontal axis. That's a tan theta equal to tan theta equal to opposite side by adjacent side, that is V by H. Tan theta equal to V by H. Then theta equal to tan inverse of V by H. In that manner, that's why tan theta comes. It's the slope. Here, not slope here. The theta is represents the direction of the resultant force. Okay. Theta represents the direction of the resultant force. The direction of the resultant force, theta equal to tan inverse of V by H. That's why tan theta comes. So tan theta, importance of this tan theta also plays very important role in mechanical engineering. In the field of engineering, this tan theta also represents the slope. So when curve is different, what is the slope of the curve? Suppose if we consider this, there is a linear curve is there. What is the slope of this linear curve? This is the slope. Tan theta equal to, again here it comes the tan theta function. Tan function is very, very important in the field of engineering. Now how to apply these forces, okay, this triangle of forces in order to find out the resultant force. Here let us start the problem. The two forces are acting at a point O is shown in figure. What are the two forces are? The force P and force Q are acting. So force P equal to 50 newtons, force Q equal to 100 newtons. Now it is a 15 degree. Force P is making with the horizontal axis 15 degree. What about force Q is making with the horizontal axis, that is 45 degree. Now how to make it resultant of these two forces? That is what we have to find out. That is determine the resultant in magnitude and direction. Then what is the horizontal? What are the horizontal component? The sum of horizontal component of forces, that is P cos 15 degree plus Q cos 45 degree. What is the value of the P here? 15 newtons cos 15 degree plus Q 100 newtons cos 45 degree. Now what is the value of this horizontal component? That is H equal to 119 newtons. And similarly V, vertical component of the forces, V equal to P sine 15 plus Q sine 45. What is the P and Q? Substitute out there, then the resultant V equal to 83.64 newtons. Now the P is the positive and sigma H, that is H is the positive value, V is the positive, upward direction is the positive Y. Then what is the resultant? The diagonal represents the resultant. This is the diagonal R. How we get this R? This R equal to under square root of V square plus H square according to Pythagoras theorem. What is the V equal to? Here substitute V equal to 83.64 and H. What is H value? 109 newtons. That is substitute and the resultant is obtained as 145.46 newtons. 145.46 newtons. That is the resultant. What is the direction? The direction of this is the magnitude of the resultant force. The direction theta, tan theta equal to V by H. We know V value, tan theta equal, what is the value of the V? The value of the V is 83.64 and the value of the H is 109 newtons. Then theta value is obtained at 35.10 degrees. So when two forces are acting here, the P and the Q, 50 newtons and 100 newtons are acting. These two forces, the effect caused by these two forces is equal to the effect of the same resultant, the resultant force. The value of the resultant force here, it is 145.46 newtons with the direction with which it is affecting. The direction is that the angle of this resultant force is 35.10 degree. Theta is 35.10 degree when it is acting, pulling the body. Single force, that single force is known as the resultant force. The effect of these two forces, P and Q, on the particle is replaced by a single force, that is the resultant force, that R equal to 145.46 newtons, with the direction, with the angle of 35.10 degree. Alright, that is here P and Q. The P and Q's here, understand, 15 newtons P is acting with the angle of 15 degree, and Q is acting with the angle of 45 degree with respect to the horizontal axis. Then 100 newtons, this 150 with the different angles are acting on the body, particle O. These two forces are replaced by a single force, that is resultant force, by using the method of resolution of a coplanar force system. Okay, let us begin with another problem. You can understand better. So there are three forces of magnitude, that is 40 kilonewtons, 15 kilonewtons and 20 kilonewtons. Three forces of acting of magnitude, that is 40 kilonewtons, 50 kilonewtons and 20 kilonewtons. At a point O is shown in this figure. Now the angles made by 40 kilonewtons is 60 degree, 15 kilonewtons is 120 degree, and finally 20 kilonewtons is making with 240 degree. With a reference to what axis? X axis here. So we can apply directly the formula of for this methodology, that is H equal to R1 cos theta 1. Suppose R1 is 40 kilonewtons, R2 is 15 kilonewtons and R3 is 20 kilonewtons. H equal to R1 cos theta 1 plus R2 cos theta 2 plus R3 cos theta 3. Now here what is the R1 value? That is substitute directly 40. What is theta 1? Theta 1 equal to 60 degree. Cos 60 degree plus R2, that is 15 kilonewtons, cos theta 2 120 degree plus R3 20 kilonewtons, cos theta 3 240 degrees. This H value is obtained as 2.5 kilonewtons. Okay. Next, if you want to find out, now what about vertical component? In the case of vertical component, the vertical component V equal to here R1 sin theta 1 plus R2 sin theta 2 plus R3 sin theta 3. Substitute R1, R2, R3 and theta 1, theta 2 and theta 3 in this expression, then the values obtained for V equal to 30.31 kilonewtons. This V equal to 30.31 kilonewtons and H equal to 2.5 kilonewtons. The value of H is 2.5 kilonewtons. V is 30.31 kilonewtons, H equal to 2.5 kilonewtons. What is the resultant force? Both are positive values. Both are positive values. This is the H value, that is 2.5 kilonewtons, and V, that is V equal to value of the V equal to 30.31 kilonewtons. The resultant moves. This resultant R equal to under square root of V square plus H square. That H square plus V square comes as 30.41 kilonewtons. What is the direction with which it is acting? With the horizontal. That is theta equal to tan inverse of V by H. If we substitute, after substitution of V and H values in the formula, then theta is obtained as 85.28 degrees. So when two forces, here the coplanar forces system, that 40 kilonewtons is making with 30 degrees, 60 degrees, and 15 kilonewtons with 120 degree and 20 kilonewtons with 240 degree. When these three forces are R1, R2, R3 acting on a particle O, this or the effect of R1, R2, R3 with the directions of theta 1, theta 2, and theta 3 are replaced by a single force, that is R resultant. That R resultant force, that R equal to 30.41 kilonewtons with the direction of 85.28 degrees equal. These are all the forces, 40 kilonewtons, 15 kilonewtons and 20 kilonewtons, and with the theta 1, theta 2 and theta 3 are acting on a particle. All these forces effect is equal to the resultant force, that is R 30.41 and theta is 85.28 equal, that is equal. This force is known as the resultant force. Again, which method we have followed? We followed resolution of a coplanar force system and find out the resultant force. So this methodology is very important in order to find out the effect of number of forces. In the real field problems, there will be number of forces acts on your body. Then how to make it balance with the single force? Okay, that is known as the resultant force. This concept of resolution of the force is very important in the course of a theory of machines, where the module is the balancing of forces system, where again it is applicable. Resolution the horizontal and vertical components. Then we'll make it sigma h, sigma v and find out the resultant. That resultant force is the finding out that resultant force is the balanced force of all the other unbalanced forces. So that's why the concepts of engineering mechanics is very important and highly required for engineers of civil, mechanical and aeronautical. Now let us begin the next problem. We are going to find a solve. Here all the problems I considered only with the magnitudes made by different forces with reference to the OX. So there is no confusion, you can substitute directly. Now for in some cases we get the problems with different axes, with the vertical and horizontal axis. Some of the reaction forces may act positive y-axis, some of the reaction forces may act with the negative x-axis and negative y-axis also. For such cases, how to apply this resolution of a force of a component, resolution of a force system, of a coplanar force system. But after solving this problem, we are going to attempt such problems. Now let us begin. Here, four forces of magnitude 10 kilonewtons, 15 kilonewtons, 20 kilonewtons and 40 kilonewtons. There are R1, R2, R3 and R4. There are four forces are acting at a point O. With the angles, the direction of those forces are 30 degrees, 60 degrees, 90 and 120. We are having equal consecutive 30 plus 30, 60 plus 30, 90, 90 plus 30, 120. In that manner, but find the magnitude. What is the magnitude and direction of the resultant force? The magnitude and the direction of the resultant force we need. Let us same methodology we have to follow. That is H equal to, again I am writing here even though it is mentioned here, but after writing you can understand better. H equal to, that is R1 cos theta 1 plus R2 cos theta 2 plus R3 cos theta 3, and one more is there, R4 cos theta 4. What is theta 1? 30 degrees, theta 2, 60, theta 3, 90, theta 4 is 120. And whatever R1, R1 is 10 kilonewtons, R2 equal to 15 kilonewtons, R3 20 kilonewtons, R4 equal to 40 kilonewtons. Substitute R1, R2, R3, R4 and theta 1, theta 2 and theta 3 and theta 4 in the derived in here mentioned expression, that is 10 cos times theta 1 30 degrees, R2 15 cos 60 degrees plus R3, what is the value of R3? 20 cos theta 3 90 degrees, R4 40 cos theta 4 120 degrees. The value obtained here for this is, okay, equal to, that is my negative of 3.84 kilonewtons. Negative of 3.84 kilonewtons, that is H value. Whatever the V value, the value of the V equal to R1 vertical term sin theta 1 plus R2 sin theta 2 plus R3 sin theta 3 plus R4 sin theta 4. Whatever R1 here, the R1 equal to 10 sin theta 1 30 degrees, R2 15 kilonewtons, sin theta 2, what is the sin theta 2? That is 60 degrees, R3 that is 20 kilonewtons, sin theta 3 90 degrees, plus R4 40 kilonewtons, sin 120 degrees. So here the value, after calculating the values obtained here, V equal to 72.63 and H equal to, here the value obtained V is the positive value. So positive value, that is negative value H equal to the obtained value of the H, negative of 3.84 kilonewtons, and the positive V, the V value is 72.63 kilonewtons. Okay, 72.63 kilonewtons. Okay, now how to get a resultant force in what direction? If we consider the positive X, negative X is the positive Y, upwards, downward, vertical downwards is negative Y. Now which quadrant system? The negative X here and the positive Y. This is the resultant force. The V equal to 72.63 kilonewtons, whereas H equal to 3.84 kilonewtons. The negative X direction. Now in this direction resultant acts. With this direction, whatever theta, the value of the theta with which it is making. Thus, yeah, what is the R value? The R value R equal to under square root of H square plus V square. Alright, what is the H value? H value is 3.84 negative whole square plus the V value 72.63 kilonewtons whole square. This is the R value. What is the direction of this resultant force? Tan inverse of V by H, 72.63 by 3.84. That is the theta. Let us here, H value, we got it, here it is. R value resultant, the magnitude of the resultant force is 72.63 kilonewtons. Yeah, the direction, you can see the direction of the resultant force. Then whatever theta, the tan theta equal to V by H, I consider with this that values obtained as 18 point, that is 90 degrees and 180 degrees, that is 18.91 degrees tan theta, that is okay. With this angle it is making 90 minus 18 point, that is 86.97. Now with respect to the theta with the horizontal x-axis, that is 180 minus 86.97. Then 180 minus 86.97, how much? That is 93.03 with this x-axis. But the theta here, the resultant force is acting in this direction. Please understand here how to find here the forces, number of forces are acting here, R1, R2, R3 and R4. The number of forces are acting R1, R2, R3 and R4. There are 4 forces are acting on this. In the angles are all are moving here, this direction, yes. But the effect of all this resultant, the resultant force is passing through somewhere else, like that, resultant force. How much angle it is making? With 80 point something, 93 degrees. The resultant force which is acting, that is 93 point, yeah, 86.97. 86.97 degree it is making, 86.97 degree with the axis. With this resultant is acting in upward direction. Okay. We can see here it is 60 degree R4, but the angle with which the resultant force R is acting with angle of 86.9 some degrees. Yeah, this is the magnitude. With this direction, the resultant force is acting with the magnitude of, what is the magnitude of the resultant force? 72.73 kilonewtons. The magnitude of 72.73 kilonewtons, 72.73 kilonewtons with this magnitude. So, the effect of R1, R2, R3 and R4 having the magnitude directions of 30 degrees, 30, 60, 90 and 120 degrees acting on a particle O, the effect of all these forces, the effect of all the forces R1, R2, R3 and R4 with the direction of theta 1, theta 2, theta 3 and theta 4 is equal to the effect of resultant force and its magnitude theta. The magnitude R, that is 72.73 kilonewtons, and theta is 86.97 degrees. 86.97 degrees. Then what will happen to the system? The system will be in equilibrium. Already these forces are acting, so all these forces effect equal to this force effect. So on a particle O on the particle, this R is acting with 72.73 kilonewtons with the direction of 86.97 degree. So this is the concept of resolution of a coplanar force system. Now, instead of acting number of various forces with the different quantities with the various magnitudes, all these forces can be replaced by a single force. The effect remains the same. That force is known as the resultant force. Resultant force. How do we found this, the resultant force? By using the concepts of resolution of a coplanar force system. By using a coplanar force system, we found the resultant force. Okay, that is the problem. Next. Suppose some of the forces are acting R1 with the direction of theta 1, R2 with the negative x-axis, and R3 with the negative y-axis. Okay? For this type of cases, how to find out the resolution of force? The way we followed the before, we have to make it R2 with x-axis. We have to transfer the theta to this R2 angle with the OX, then you can apply. Now, similarly, R3 again 270. Yes, 270 minus theta 3. This is the angle will come with OX axis. There is another method. What to do? We can resolve here itself directly. Draw horizontal and vertical lines parallel to x-axis x and axis y. Then this is theta 1 here. It becomes R1 cos theta 1. Here it is R1 sin theta 1. Now draw horizontal and vertical parallel lines. The direction of R2 here, that becomes R2 cos theta 2. Then it becomes R2 sin theta 2. Now we draw parallel and perpendicular lines to both x and y axis. Here it is theta 3. Then this component becomes R3 cos theta 3. R3 and R3 R3 cos theta 3, and here you can also make it R3 sin theta 3. So we can, here the point is that all these things we can make it the sigma h equal to sigma h equal to R3 sin theta 3. Sigma h R3 cos theta 3. Let me mention here. Now, sigma h equal to, what is sigma h value? The positive component R1 cos theta 1. Next, the negative component, here it is, that is minus R2 cos theta 2. The negative component of R3, that is minus R3 sin theta 3. That is sigma h. Whatever sigma v equal to all vertical components you consider here. The sigma 3 here, that is R1 sin theta 1 plus R2 sin theta 2. Whatever R3 vertical component is vertically downwards, the negative y-axis, minus R3 cos theta 3. Now, after knowing this sigma h and sigma v, the resultant force are equal to under square root of sigma h square plus sigma v square. And the direction theta equal to tan inverse of sigma h by sigma v. Sorry, sigma v by sigma h. My point is that here, in before problems with respect to OX, if you consider this case study, in H components, sum of H components, all are cos terms, you can observe. And vertical terms in V equal to all are sin terms. The way I solved here in this problem, sigma H, it is there positive and negative terms. Alright. And sum of cos terms and sum of sin terms. This sum is known as algebraic sum. Algebraic sum of all horizontal components, that is sigma h. And algebraic sum of all vertical components, that is sigma v. Here also sin term and cos term. It is not necessary the way we are taking the reference of the direction. The direction of reference axis, if we consider it, the manner it will change the directions. So towards the left positive x, and towards left negative x, towards right positive x, upward vertical upwards positive y, downwards negative y. So by using those conventions, we can calculate the resultant force by using the method, that is another method. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.